So brute force method, 1/12 and 2/15ths. I'm going to multiply each one by the other for this method. So a 15 here and a 12 there. If I do it to the bottom, I have to do it to the top. What is 12 times 15?
180.
Oh, okay. Whoops. 1 times 15 is 15, 2 times 12 is 24. Add them up together, I get 39 over 180. Can I reduce this? Remember our divisibility rules. 3 plus 9 is 12. So yes, this top number is going to be divisible by 3. Is it divisible by 9? No, because 3 plus 9 is 12, and 9 doesn't go into 12, but we can at least do it divided by 3. So I will get 13 and 60. And if you needed a calculator to do some of that, that's not too bad. Let's try the list of multiples method. So I'll start out writing the same thing. So what are my multiples of 12? 12, 24, 36, 48, 60, 72. Hopefully that's big enough. Let's switch to 15 for a while and see if we got it. So 15, 15, and 15 is 30, 45. 60. Here we go. 60 is on both lists. Everyone okay with my list of multiples? So on the 12s, I did times 1, times 2, times 3, times 4, times 5. Oops. On my 15s, I did times 1, times 2, times 3, times 4. So we wind up with 5 60ths and 8 60ths is 13 60ths. Questions about either of those two? If you like the prime factorization method, then first in blue, we have a 12. That becomes a 3 and 4. And the 4 becomes a 2 and a 2. In green, we have the 15. That becomes a 3 and a 5. And that's all we get. So I'm going to write down the numbers that's on both trees and cross them out on both trees. So what's that?
3 and 3.
The 3. And that's all that's in common on both trees. So because of the 12, I have to do a times 2 and a times 2. The 12 had that, so the 15 needs that. So I'll put that on the 15. Because of the 15, there's a times 5, and the 12 didn't have that. 5. So I need to put it there. So now they both have the same things. And that's equal to 60, by the way. Kind of crowding my space. There we go. So for a very different way of thinking, we get the same thing, 5/60ths plus 8/60ths is 13/60ths. If you want an extra challenge, then you can do the same thing with 3 numbers. It's the same, it's the same process. Can I do that? Let's do this as a warm up next class. Okay. If you try it the brute force method, you're going to get some very big things, multiplying 3 numbers. If you're doing the list of multiples, suddenly that looks a lot more attractive with 3 numbers, right? What's going to be the, you can just see it making the list. What's my least common denominator going to be? 30, right? All 3 of those were, well, no, 4 doesn't go into 30. 60 will work. So you'll make each list up to 60, and it doesn't take that long even for 4s. In the prime factorization, you'll make 3 trees, play the same game, and you'll see that you get 60 when you do the thing. So it will work, but let's use this as a warm up for next class. It'll be good for that.
You do the, well. I'm honestly something to like the prime factorization. I've been a whole lot of it.
You're allowed to change your favorite, nothing wrong with that. Okay, but, oh, I should stop my recording. Doo-doo-doo.